Okay, hello everyone. My name is Timothy Lee Grant, and welcome back to another engineering inquiry video. So, in these videos, what we do is we just try to go and find different concepts within engineering that I don't quite understand, and then go through the video and explore it. So, it's kind of just a low-key, chill type of video that we're just exploring engineering concepts. So, what we're going to do is in the last video, I was trying to get how does Pinvoke work within C sharp, and the idea behind Pinvoke is if we have a library or a piece of software that is written in a separate language, so like C, if we have some C code that we want to run, but we're in C sharp, how do we run this C code? So there's this way in C sharp is that you can do something called pinvoke. And the idea behind that is you are able to evoke this C code and then go back to your C sharp code. So it's managed and unmanaged. So that's kind of what we're trying to do. So in the last video, the point that I got to was I I don't know anything about what's going on in the code. I have zero understanding, and all I did was just go to ChatGPT and copy and paste everything to try to get something that worked. We got it to work. Now it's time to go in and investigate why is it working, how is it working, what does each line do, and why is it the way that it is. So let me minimize myself a little bit, make myself smaller. There we go. So here it is. Now what we have is we have this mylib.c right here. It's just a very simple function, just add, okay? It takes in two parameters, a and b, and just returns the addition of them. Then I did a .NET create, so I created a .NET project, and inside of here we have this class program. Now, then I try to call this add function, and notice public static like extern, so it's called somewhere else, or it's defined somewhere else. So I was able to run it and successfully get the correct answer. It says the addition right there. Okay, so how did it find it? And now let's try to make it a little bit more complex as well. So all right, so let's try to understand it. Like, what is this right here, and how does it? So I see that these two things are the exact same, okay? Calling convention, I don't get that. So let's come in here, and we're gonna come right back here and say it worked. Now I want to understand it more. Can you go line by line and explain it fully? And I guess I didn't even need to copy and paste it because it's I just said let's do it this way. Okay. Let me actually get that as well in there. There we go. Now we're charging. So it's bouncing up and down while it's thinking, and let's looks like it's done. Let's look into it. Okay, so you built a tiny native C library and called it from C sharp. That's right. The bridge is pinvoke. Okay. So it's this strategy right there. All right. So, which tells .NET load this native library, find this function, and call it with these exact types. Okay. With these exact types and this calling convention. So I need to kind of understand what every single one of those items is. Okay. Find this function. That kind of makes sense. With these exact types, I'm guessing that means int right there, or what? Okay, what? I need to figure this out. The other thing is I don't know about this export. I haven't really seen that before. Okay, so here in mylib.c, a comment naming the file, no effect on compilation. Did I really read that line? Okay, yeah. Thank you. Okay. So, a preprocessor condition that's true when the compiling is on Mac OS. Okay. It lets us write Mac specific code paths. So I want to know what this is, like attribute. Okay. So define export. Okay, so this right this right here is a define macro. Okay, so defines a macro named export. So this is kind of a custom macro that we are creating ourselves. Okay, I guess I didn't see that when I was. Yeah, okay, so here we're defining this macro export, and it is defined as whatever this is, attribute visibility default. Why is that important? I don't really know, but we'll figure it out. Okay. Defines a macro named export. On Mac OS, Clang. What is Clang? I know that that was one of the commands that it was telling me to run yesterday, but I don't know why I was doing that. Functions have hidden visibility by default when building shared libraries, unless you change it or set a global flag. Okay. Marks the symbol as publicly visible so that the dynamic loader and .NET can find it. Okay, I think what... Okay. So I'm going to do this, and I'm going to say number 1. Can you explain this more fully? Also, is this because when you compile it, I don't know how to spell this, obfuscates. Skates. All of the names and items in the code. Okay, so that's question number 1. Follow-up question number 1. So else it, okay, we don't care about that. Okay, so export. So we're sending this, declares and defines the function. Yeah, so we're sending the function itself to that export. Okay, export ensures the function symbol is exported in the. I'm guessing we can't open this. Yeah, okay. So it's exported in there. Int add. So signatures return int. Yeah. And we get that. Okay. So now building the library. So here's Clang. All right. Key idea, the function name add must be exported and unmangled so .NET can look it up by that exact name. In pure C, names aren't mangled. If you ever compile a C++, you'd use extern C to prevent mangling. Okay. Clang. Oh, okay, so Clang is similar to maybe G++. Shared, produce a shared library, dynamic loaded, instead of an executable. So we don't want to create an executable, we just want to create essentially that DLL. The second thing is, what is the difference between a dylib and a DLL? What is a DLL? Okay, so let's follow up question number 2. Okay, so fpic. Generate position independent code required for shared libraries. Position independent code. Okay. Number 3. What does position independent code mean? And what do you mean required for Shared libraries. Okay. So minus O here, output file name. So we're just creating the file name. Okay, that's fine. Shared libraries use the dylib extension, and convention begins with, okay, fine. Manage C# code. So this is our C# here, okay. So now I want to know about this line right there. So that's fine. Okay. I don't know what system runtime interrupt service is. I don't know what that means. I've seen it before, and it was something that I kind of glossed over. So now is a perfect time in these engineering investigation videos to actually understand what that means. Okay. So, actually, maybe it answered it though. Let me look at it. Imports interop types and attributes like, okay. So follow-up question number 4. This explain this more fully. Okay. Define class program. Okay, that's fine. All right, here we go. So DLL import, an attribute declaring that a function is implemented in an external native library. Okay. So attribute is an attribute declaring, so just telling the compiler that a function is implemented somewhere else. Okay. It also tells the runtime which library to load and how to call the function. Okay. So here is where you load it, that DLL. The library file name to load. The runtime tries typical locations, the current process directory, the app's output directory. Okay. Calling convention, this is another one that I didn't know. Specifies the native calling convention. C functions use cdecl by default. This must match the native side. If it doesn't, calls can crash because arguments and returns are handled differently at the ABI level. What does ABI mean? Okay, number 5. What is ABI level? And what are the different calling conventions? What is a calling convention? Okay. So, public static, accessible and callable without an instance. Okay. Extern here. Maps just compatible. So another question that I had, like, we need to make sure that it's the same number of bits, right? Signed on both sides, because both of them agree with the definition of int. Okay. Name binding. It's name binding. Where do we see that? By default, .NET looks up the symbol add in the library. Okay. If needed, you could use entry point equals add to bind to a different exported name. Okay, so we can call it the function a different name, but we'd have to tell it like entry point is at. Okay. Kind of makes, I don't know. Console write line here. Yeah, that's fine. Okay. So, how the pieces fit together. Let's do a high level, and then we'll ask these follow-up questions, and then maybe go back into the C code or the C# code and see if we can get it a little bit more complex. Okay. So how the pieces fit together. Library loading. Library loading. When the program first calls add, okay, the runtime loads that DLL if the file isn't present. You get DLL not found exception, okay? Symbol lookup. The loader searches for a visible function named add. The loader, okay? That's why the export visibility and consistent naming matter, okay? Calling conventions, CDecl defines how parameters are passed and who cleans up the stack. Matching it prevents ABI mismatches and crashes. We're going to ask that as a follow-up question. Marshalling. I've heard about marshalling. I don't know what it is. Okay, this is important, I think. Maybe. I don't know. Marshalling. For simple, blittable types, like int. What is a blittable? Okay. What does blittable type mean? The runtime passes values directly with no copying or translation. More complex types like strings, arrays, and structs require specific marshalling rules. That'll be our next thing when we want to make it more complex. We're going to do that marshalling. Okay. Common questions answered. Why visibility default without it? Or glow. Your function might be hidden inside the DLL and not discoverable by the loader. Export visibility makes the symbol public. Why decl? Plain C on Mac uses decl. If you used a different convention on either side, it can fail or produce garbage results, okay? Where must the DLL live? Same directory. Okay, fine. Do C and C# ands always match? Okay. So this is what we're going to do next, like passing in different arguments. Passing and summing an array. Converting a string to a character array. Okay, returning data types. Handling memory you allocate in C. Okay, let's ask these follow-up questions. And then, so another thing that I want to do, we probably won't get to it in this video, it might be the next video, but I want to understand how we can use callback functions from one to the other. So like what if I want to trigger an event in the C and then I want to get notified in my C#? That's something, right? Like all right, so attribute. Okay, so let's go through this attribute visibility default. Let's try to see what it does. This is a compiler directive specific to GCC or Clang, okay, that marks a symbol. And, okay, good vocabulary word. Symbol means function or variable as publicly visible outside the compiled object. Okay, when you build a shared library, not all functions are automatically exported. By default, modern compilers often hide symbols to reduce namespace pollution. Okay, ensures function name is exported so dynamic loaders can find it. Okay, not obfuscation. It doesn't rename or scramble symbols. It's about visibility, not hiding names. If you don't mark it, the function might exist internally but not be discoverable. Okay. So it's just about like playing nice, I think. Not really about trying to protect against like back engineering or something like this. Difference between dylib and DLL. Dynamic, so DLL is dynamic link library. The Windows format. Okay, that's why. Okay. The Windows format for shared libraries. Hmm. Okay, contains compiled code and exported functions that other programs can load at runtime. Ah, okay. So now the dylib, this is for Mac OS. Okay, same concept, compiled code. Okay, great. So SO, this is the Linux equivalent, all right? And the only difference is naming. Awesome, awesome. Okay. Position independent code. Okay. Let's I'm gonna take a sip of water. Oh man. Okay. So, position independent code. Code that can be run correctly regardless of where in memory it's loaded. Doesn't assume fixed addresses for functions or dates. Okay, or data. I think this is like an assembly concept because in assembly you have like jump and then you say what memory address you want. So I think what's going on is I'm telling the compiler to make the code in such a way that it doesn't require like jump and then a like hard coded memory address. So I'm gonna say this for call function. Okay, actually, maybe we should read a little bit more. Okay, why required for shared libraries? Shared libraries can be loaded at different memory addresses in the process. If the code assumes fixed addresses, it breaks. PIC uses relative addressing so the loader can place the library anywhere. So I think relative is going to be like move 20 positions up or like whatever, 2,515 positions up. So like current location plus 2,515 and go to that memory address. So instead of call function at absolute 1000, PIC says call function at offset plus 200 from here. Yeah, exactly. There we go. Okay, we don't need this. So, using system runtime interop services. I don't think this has to do with like the Pinvoke, but it's more of just it's something that I've seen before, and I want to at least know generally what it is. So purpose. This namespace in .NET contains types, attributes for interoperability with unmanaged code. Okay, so this. Never mind. This is for Pinvoke. Key features. Oh, so this is where DLL import attribute actually comes from. Declares external functions in native libraries. Marshal, which we haven't gotten to yet, but we need to. Provides methods to convert between managed and unmanaged types. Okay. GC handle lets you pin objects in memory so unmanaged code can safely reference them. Interesting. Struct layout attributes. Struct layout, field offset, control how managed. Structs map to native memory. Okay. Yeah, we might also need to try to do structs too. Okay. Without it, we can't declare this. So yeah, we probably pretty much need that. ABI level and calling convention. So ABI, application binary interface. The contract between compiled code and the operating system. Okay, so this has to do with the compiled code, like my executable maybe, and how the runtime or the operating system actually executes it, I think. How functions are called. Stack register usage, how data types are represented in memory. Okay. How return values are passed back. How structures are aligned. Calling convention, a specific part of the ABI that defines how parameters are passed and who cleans up the stack. So decel, parameters pushed right to left on the stack. Caller cleans up. Default for C functions on, okay. STD call, parameters are pushed right to left. Call tree cleans up. Common in Windows APIs, okay. If your managed declaration doesn't match the native convention, the stack is misaligned. Okay, so this is trying to deal with how the memory is actually dealt with. I'm not even gonna pretend like I really understand this, but I just know it's something to like keep in my head right now. Okay, there is something which is this calling convention. There's ABI and there's a couple others, and the two codes need to match. A blittable type. So a blittable type is one that has the same binary representation in managed memory. So C sharp and C. Okay, so they're interchangeable. Non-blittable is string and boolean. Arrays structs with references. Okay, these require marshalling. Awesome. Because their managed representation differ from native. Why it matters, blittable types can be passed directly with no overhead. Awesome. We like that. That's good. That's good. Okay. Awesome. Okay, so now let's change this to be, let's just see if we can do this. 3. I'm going to change that to be 3. Okay. Then I'm going, no. There we go. Okay. So now I can't say that even. What did I say? Change that to B3? And the Apple Assistant comes up? So now that's the second one. The first one was when I try to do this command. Right there. Those two letters combined together. And then the Apple Assistant comes up. Okay. Anyways. So we put 3 in there. Go away. Okay. Now I need to come in here and change this, and this is also going to be an int C. Wait, who are you? Go away. I mean, that's what I wanted to do. Wait, am I going crazy? Wait, what? Who? I mean, it's what I wanted to do anyways, but... Okay. That was weird. So now what I can do, I need to compile my C code. Okay, so let's come here. Let's check where we are. Go up a level, and I need to compile it. Now let's, so we're just doing these steps again. Okay, we're doing the steps again so that we get it in our head, right? So we need to compile it with all of those flags. Yesterday in the last video, we were just throwing things, right? I took it, copy, paste, copy, paste, copy, paste. Right? Uh, get an error, put it back in to ChatGPT. It gave me an output, copy, paste, back and forth. Now we're trying to actually understand it. Okay. So let's come here. Okay. So let's go one by one. So clang, okay. Clang. Now shared, and then that F, the PIC, that means in place, right? That was the in place one. And now output file, and we want the output file to be that we're gonna say, hey, name it lib mylib, and then it's going to be of type dylib, because that is Mac's version of DLLs, okay? And then we want it from mylib.c, okay? All right. And then we need to go into the evoke, okay? Put this into the .NET Finder. Okay. So can I just, but I don't really want to copy it. Fine. Okay. So I think I'm still in there, right? Yeah. So we're just gonna copy this current directory, okay? Lib mylib dot dylib, and I probably actually should delete this one just to make sure that we are actually legitimately replacing it. And where do we want to put it? We want to put it inside of pinvoke bin debug net9. Okay. There we go. We put it in there. Awesome. And then I think we need to do .NET build. I don't think that's actually correct. Yeah, that's not going to be correct, right? I don't know why I'm doing this, but yeah, okay. I just wanted to make sure I wasn't going insane. Alright, make sure, cannot find a project to run. Okay, well, I got what I was expecting, but for the wrong reason. Okay, let's try it again. .NET run. We weren't in the right file, but I'm expecting to crash because yeah, it takes 3 arguments. That's what I was expecting. Awesome. So we need to build it. The world is in order. What do we want to do? Where is it? Is it just .NET build? Like, or do we need those special parameters? I don't know. So this one is saying, okay, well now we understand this a little bit more. Like clang shit. Okay, well, nice. But I still want to know how to. Okay. .NET build, and then P define constants is. I actually don't think we need that because. Do we? We're not breaking off of. Because here in this C#, we were defining this OSX. But here we're no longer doing this. So I actually don't think we need this. So I think we can just do the plain .NET build. Takes 3 arguments, yes. No overloader for add. Ah! It. Uh-huh. I caught you in the act. Yes. In C, that's correct. Okay. .NET build. .NET run. No, that's not right. Oh, yes, it is. Okay. Well. And this is going to fail because we're in the wrong library, but that's fine. There. And now we should be able to just run it again. When we are in the right library. Okay. Build succeeded, yes. .NET run. So this is just statically typed. Like, that's fine, that's whatever. But result should be... should not be the legitimate answer. It should incorporate this 3, though. It's not doing that. Like, why is it not 45? Like, come in here, yeah. Oh, I didn't place it in. I didn't place it in. I didn't. Come here. You get out of here. Okay. I need to place it. Okay. Actually, I think I can just use this copy and paste one because it. Oh. We are going to paste it from one directory up, and I want this one, and I want to paste it into Ben debug net 9. Yeah. I want to copy. Come on. Now I want to .NET build. Now I want to .NET run. And we get 45. That's right. That's how we do it. Okay, let's try to make it a little bit more complex. What if I want this man what did it call? Like marshaled. This can you use the same code but make it slightly more complex. Okay. So we're going to have these types, okay? Okay. Marshal in action. We'll add functions to deal with arrays and strings. Because those require runtime in Marshal. Awesome. So let's include C type and string in our C code. Okay, so hashtag include C types. Okay. Hashtag include string. Yeah. We're still gonna have this, and now I want to export. I want to export a double. So right now what I'm doing is I'm just copying this but I'm not actually just like doing a copy and paste because I kind of want to do it through. Actually, well, this kind of just is boilerplate code. I actually, never mind. I might copy and paste this because this is just a boilerplate code right here. This one doesn't matter. Okay, that's fine. Awesome. Now I want to. Is this anything interesting? To upper character array. No, this isn't interesting either. So we can just paste that in. Now, obviously, I'm not interested in this. I don't care about this. I don't care about this. What we're interested in is how do we get a character pointer, so a string. How do we get that in here? How do we get a double pointer in here? Like, that's what we want to do. Okay. So now we have to compile this the way that we normally do. So okay. Got it. Now we need to come in here, and this is going to be more interesting. Yes. But we still need to copy this in. So let me come here and do that copy. And make sure that I delete this. Delete. Oh, move to trash. Okay. Then do this, and it should come up. Nope, because I am... No such file. Okay, come on now. Okay. So we are going to do Pinvoke. There we go. And you are going in here. Thank you. And there you are. Awesome. So now what we're going to do is come into here and we're going to... Now we're not going to copy and paste because this is the important stuff. Okay, so class program, awesome. We have this one here, which is normal. That's the one that we already have. Okay, so now what I want to do is I want to come in here, and I want to like follow along with this. Okay. Okay, there we go. So now we want to add another one, right? That's gonna come here and then do D import, okay, and then we're doing the exact same file, which makes sense. We're saying, hey, that file that we just loaded into our .NET project, look in there. That's the DLL, right? So okay, well, it's already there for me. Live like this, yeah. And then now calling convention is the same thing here. Calling convention is going to be equal to calling convention dot cdel. Calling convention dot cdel. Okay. And we got that. Okay. So now what I want to do is I want to say what I'm actually going to be exporting, right? So we're going to say public static extern, which is defined outside of here. And what? No. Hey! Do you guys see that? What the heck? Okay. Public static extern double. Sum array. Okay, so all of this is the C# stuff, and then double matches up with this double, and then sum array. Okay. Now we have to do these weird things, and I don't know what that is. That might be the marshalling. So we have here. Okay, so now we do double. Okay, of type double and sum array. Same what? Same name, yeah. And now brackets. I don't know why brackets. In. What does in mean? We don't know yet. Double like this. Okay. Values. Int length. Awesome. Now we're going to do the exact same thing for the other one. So now we do like this. DLL import. And then, yeah, libmylib.dylib here. Calling convention is this. No, don't you dare. No, get out of here. Go away. I want to write that. Okay. Here we go. This one's private. Look at that. Private static extern void. And now we're doing that to upper. So to input. Okay. So we do this, that's fine. Now we do the marshalling. So now let's come here and let's say we're going to do array marshalling, right? So double here, array, we're just creating an array. Okay, whatever. Yeah, let's just copy and paste this actually. It's fine. Okay. Wait, why? There. So now I'd want to do Yes. Yes. Like, what? Okay. Console right line. Right line. And then, let's see, yeah. $, sum underscore array. Yeah, is equal to sum. Yeah, that's right. So now, string yeah, that's correct. How is this marshalling though? Here's marshalling. I don't see marshalling going on here. Are you? I'm not seeing anything. I see the marshal dot string to here. Okay. So I don't know if this is gonna work. S is equal to hello world. Yeah, that's right. So now what I want to do is I want to say int pointer. Where is this defined? Where is int pointer defined? Where is this defined though? Int pointer here. Okay. Question is int pointer seems to be created out of nothing. I didn't define it anywhere, but I am able to use it. Okay. So, oh, it's within system. Okay, fine. It's just within the package. It's fine. Now I want to say unmanaged is equal to, here we go, marshal dot string to global to global and C for some reason. Okay. And then 2 underscore upper, and then unmanaged this. Okay. 2 upper. So I'm passing in this data type to upper, which is here. Okay. And the type needs to match somehow. Okay. Well, I'm going to see if this works. And then if it does work, yeah, let's just get something that works first. Upper is equal to, and we're going to do that same trick. Marshal dot pointer to string ANSI unmanaged with an exclamation at the end. I don't know why yet, but, and then freeing memory, marshal dot free, and then h global of unmanaged. Okay. And then console dot write line, and then let's see, is this correct? We'll change it. Okay. I just want to do this. There we go. All right. And it appears we have a problem here. Did I cut off the... I cut off this one? Okay, yeah. Come on, what's... There. Okay, awesome. We already did this. Let's do .NET Run. Let's just see if it works. .NET Run. Calling convention. We did it here. This is... This one must be correct, right? Because... Although this one is not being highlighted, so it makes me think that I probably made a mistake. So paste you in there. Okay, let's run you again. We'll build .NET build. Okay. .NET run. Okay, so we got the uppercase hello world. Okay, so it works. The next thing that we need to do is understand like why it works, but it's almost 1 a.m. again, and so I'm gonna head to sleep. And then in tomorrow's video, we need to do a couple things. We need to investigate why this worked, understand a little bit more about that marshalling, and then I want to get into the callbacks. So that's kind of the roadmap of how we're going to be moving forward. Anyways, thank you guys for watching this video. If you liked it, subscribe. I would love to have you along for the journey. Yeah, so my name is Timothy Lee Grant. I'll see you guys in the next video tomorrow. Bye.